Bismillahirrahmanirrahim. Assalamu alaikum. We have our 24th lecture of formal methods for software engineering, and I am Fakhr Lodi with you. For the last 3-4 lectures, we have been discussing algebraic specifications. The idea really is to specify the behavior of abstract data types by specifying the behavior in terms of the operations. So without looking at the implementation details, without looking at the internal data structures, we specify the behavior from outside. So this is what an abstract data type is supposed to be. और इसमें हमने देखा है किस तरीके से हम एक algebraic specification को बनाते हैं और किस तरीके से हम उसकी specification लिखते हैं in terms of the axioms. In the last lecture, we saw how can we use auxiliary functions to build more complex specifications and simplify the specifications which are otherwise complex or otherwise difficult to write. And we also saw this example where we used an existing specification inside another specification, and we said, okay, just like we write our programs, in that particular case, we would use the method specified in the other specification, already existing specification, to write the specifications of methods which are provided by this new sort or new abstract data type. Therefore, the idea really is कि जो हमने पहले से जो काम किया हुआ है उसको रीयूज हम किसी तरीके से कर सकें. आज इसी बात को हम आगे बढ़ाएंगे और देखेंगे कि रीयूज हम और किस तरीके से कर सकते हैं. रिमेंबर, इन ऑब्जेक्ट ओरिएंटेड पैराडाइम 2-3 तरीके से आप रीयूज कर सकते हैं. एक तो ये है कि आपने एक मॉड्यूल बनाया है या एक क्लास बनाई है एंड दैट क्लास इज यूज्ड इनसाइड अनदर क्लास, सो यू हैव some sort of association which could be simple association or aggregation or composition or those kind of things. So that is how you build these things from smaller classes. You put them together, associate them, and then build more complex modules and structures. Another way, another very useful and very powerful technique in object-oriented paradigm is the concept of inheritance. So what happens is that you have already created a class. You want to extend or enrich that class. You derive from that class a new class. So what will happen is you will get everything that is already there in this new class, and then you can add some new functionality or redefine some of the methods as you wish or as you like, without having to redo everything for this new class from scratch. So this is a very powerful mechanism. In algebraic specification mechanism, we have a very, very similar concept, and that concept is known as the enrichment concept. Let us just assume that the task at hand is creating a new kind of a list. So I will have a few methods in that list abstract data type, which is different from what I already had, which we defined a couple of lectures ago. So this new list will have some more operations, and some of the operations which probably have been already defined. So let us just first look at the methods supported by this new list and see what can be reused. So here is the slide for you. The methods that this new list has is the create method. Obviously, which brings a list into existence. We have the cons, new list, comma element, which adds an element to the end of the list. We have the add method, add new list and element. So these are the two parameters. And in this particular case, this adds an element to the front of the list. We have the head of new list, which returns the first element in the list. We have the tail of the new list, which returns the list with the first element removed. We have the member, new list element returns true if the element is somewhere present in the list. And we have the length function or method of new list, which returns the number of elements in the list. So these are the methods that this new list supports. If we look at these methods closely, we observe that there are a number of methods which have already been defined with exactly the same semantics, This is important to note. And these methods are create, which brings a list into existence, cons, which adds an element to the end of the list, head, which returns the first element in the list, tail, which returns the list with the first element removed after chopping the first element, and length, which returns the number of elements in the list. So these 5 methods, create, cons, head, tail, and length, they are exactly the same as we had defined them earlier on in our old specification that we saw a couple of lectures ago. However, this new list has 2 more methods, 2 new methods. One is the add, which is new list, and you add this element to this new list. And in this particular case, it is opposite to this cons, because now it is adding this element to the front of the list. And member, which tells you whether a particular element is present in the list or not. So these are the 2 new methods which are to be supported by this new list. Now the question is, we have written specification for the list which supports the 5 methods that we have talked about, and they are exactly the same. There is, if you look at the semantics, they are exactly the same. So could we just reuse that and add these 2 new methods, that is the add method and the member, to the old specification without having to rewrite the whole thing again? So this is what we are going to do and see in our specification now. So once again, the idea really is कि जिस तरीके से आप inherit करते हैं, एक पहले से बना हुआ आपके पास स्ट्रक्चर है, क्लास है, and you want to completely take it and then extend it, modify something, or mostly you're using it as it is. In algebraic specification, we do have such a mechanism. And this mechanism, as I mentioned earlier, is known as enrichment of specifications. So how do we do that? Let us first look at the basic structure. What we need to do is, we are defining this new list. It will take an element which is a generic element, and undefined is one of the elements. Undefined is, we can have this element as undefined also. So this is the name of the specification, and we have this name of the sort, which is new list. This is the keyword, enrich list. So it is saying that, it is taking everything from the list and it is going to enrich, it is going to build on top of that. And it imports integers and Boolean, just like before. We had all the methods in the list except for these 2 methods. These 2 methods are the add and member. We have add, the 2 parameters are new list and element. It gives us a new list by adding this element at the top of the list in the front. And we have this member, which tells you whether this element is present in this list or not. So these are the two new methods. What we will have to write, we will have to write the axioms for these two. Now, here we have a new concept. The question is, how do we enrich? In the previous specification, if you remember, there were three constructors, create, cons, and tail. But then we decided to specify tail in terms of cons. So there were two left. That is, we had the cons and create. And then we had the inspectors, that is the head, as well as our length. And the third one that, since we wrote axiom in terms of create and cons, and that was our method tail. Now, in this particular specification, we are adding one more constructor, and that constructor is add. And now this time we are adding this element at the head of the list. सामने उसके हम element add कर रहे हैं. And there is one inspector, that is the member. So अब हमें करना क्या पड़ेगा? अगर हम इस पूरी स्पेसिफिकेशन को देखें, न्यू लिस्ट की पूरी को देखें, सो उस पूरे में देयर वुड बी 3 कंस्ट्रक्टर्स. मैं टेल को साइड पे कर रहा हूं. दोज 3 आर क्रिएट, cons, and add. And then there are the inspectors, that is the length, head, and tail, and member, 4 inspectors. तो मैंने जो पहली जो स्पेसिफिकेशन लिखी हुई थी, दैट इज लिस्ट की, उसमें जो मेरे पहले इंस्पेक्टर्स थे, दैट इज हेड, लेंथ, and tail, they had already been defined in terms of cons and create. तो वो सारी की सारी स्पेसिफिकेशन I will inherit here. अब क्योंकि मैं एक नया कंस्ट्रक्टर ऐड कर रहा हूं, दैट इज ऐड, तो इसका मतलब ये है कि वो तीनों चीजें, दैट इज माय हेड, टेल, and length, they would need to be defined in terms of add also for this new specification. And then this member would need to be defined in terms of the other 2 constructors that are not shown here, but they are here implicitly, and that is those constructors, that is create and cons, plus this third constructor, that is our this new constructor add. So हम ये methods लिखेंगे और इसके लिए हम specification लिखेंगे. So let us try to write those axioms for these all these different methods and constructors and inspectors. So here we have, remember we had this create, we had this cons. Now we are adding this add here. So we had our methods, that is head, tail, and length, and member. We already had this head for create, and we had this head for cons. We had this tail for create and tail for cons, and we had this length for create and length for cons. So these methods then don't need to be written again. So what we need to do is, we need to write head for add, tail for add, and length for add, and we need to write member for create, member for cons, and member for add. So 6 new axioms that we need to write. So let us write those axioms. We have this head of add list element v. Now in this particular case, what is happening is we are adding this new element to the head of the list. So this will become the new head of the list. So if I want to take the head of this new list, obviously I will get this new element that I have just added. So this is what I'm going to write. Similarly, tail of add LV. Now in this particular case, I had this old list L. I have added one element here to the head. So if I chop the head, what I will get the old list back. So the answer in this particular case is L. And the third one is length. Once again, very, very simple. When I add one element, that means the length of this new list is 1 more than the length of the old list. So this is a very simple set of axioms for head, tail, and length. Nothing very special about it. You can very easily see that isme kuch bhi nahi. It makes a lot of sense. Just intuitively, you can write those things. Very, nothing complicated. Now we have to write the axioms for the member function. This member, we say, okay, what we want to do is we want to find whether a particular element is member of the list or not. So once again, we have to write 3 axioms for the 3 constructors, that is create, cons, and add, and we will find the answer. We will have to write the axioms for all 3 of those. So what are those axioms? The first one is very simple. We have this member create, comma v. Now create is the empty list. Is v member of an empty list? The answer is no. The second one is member cons Now, this is a slightly more involved kind of a question, but actually not very difficult to answer. Remember the binary search tree? Binary search tree में हमने क्या कहा था? If we were looking for an element, a key in the binary search tree, we said if that key is present at the node, when we are building this, so when we build, so we have the root node. So if the key is at the root node, we have found it. It is. Otherwise, if it is smaller, we search in the left subtree. If it is larger, we search in the right subtree, and we repeat the process again. Here we are going to write very similar recursive definition. What we are going to say here is that if this element is equal to that element that we have just used in cons operation, then obviously this element is present. Otherwise, we are going to search in the old list, and if it is present in the old list, it is present. If it is not present in the old list, it is not present. So this is what we are going to write here. So if V is equal to W, then true. Else, we say is member L comma W. That is, if W was a member of L, then we would have found it. If W was not a member of L, then we are not going to find it. So this is a very simple specification for the member in terms of cons. For the add, it is going to be exactly the same thing. What happens? In the case of cons, we are adding at the end. In the case of add, we are adding up front, head पे, और वो बिल्कुल tail पे add कर रहे हैं. So what we do is, otherwise, the operation is very, very similar. We are just adding one element in this new list. So if this element is equal to the element that we have just added, obviously we have found it. It is supposed to be there. Otherwise, if the element was present in the old list, then it would have been present. Otherwise, we are not going to find it. So once again, the same specification, the only thing in this particular case would be, instead of add, we would write cons, but the structure and composition of that axiom will exactly be the same. So this is how we have written this specification, and you have seen how we have used this concept of enrichment to sort of inherit and reuse already existing specifications and build and enrich those specifications to build more powerful structures. We are going to see another example of a very similar concept, and that is, we are going to this time build a queue out of the old specification of the list. Once again, very similar, but just another example. Let us look at the slide and look at this new example of queue. In the queue, we have the following operations. We have create, which brings a queue into existence. We have this cons operation, which adds the element at the back of the queue, end of the queue. We have the head, which returns the element at the front of the queue. We have the tail, which returns the queue minus its front element after chopping the top element. We have the length, which returns the number of elements in the queue. And we have one more operation, get, which returns a tuple composed of the element at the head of the queue and the queue with the front element removed. थोड़ा सा ये एक नया कॉन्सेप्ट है. In the previous examples, all the examples, मैंने कोशिश की थी कि I sort of show you the examples where I am returning only one element at a time, only one object at a time. Remember कि हमने stack की जब example की थी, तो in that example I showed you, I told you कि जो pop का operation है, normally that operation takes the top element, gives you the top element, and also modifies the state of the object, that is state of the stack. But I avoided that, but because in that particular case I would have to specify two things. One is the element that is returned by that operation, the value of that element, what is that value, and then the new state also. So instead of specifying it in one operation, or doing it in one operation, I used two operations. One was the top, that would give me the top element, and one was pop, that would just remove the top element and give me the rest of the stack. Here this queue is, what I'm doing here is I am adding this new function get, which gives us not only the top element in the queue, but also modifies the state of the queue and gives me a new queue after chopping the top element from the queue. तो ये यहां पर दो चीजें हो रही हैं. अब इस चीज को कैसे स्पेसिफाई करना है, इसमें दो चीजें यहां पर मैं करूंगा. जैसा कि आप देख रहे हैं कि देयर आर नंबर ऑफ मेथड्स. एक्चुअली दिस क्यू, अगर मैं इस आखिरी मेथड को निकाल दूं, दैट इज द गेट मेथड को निकाल दूं, तो ये आपको एग्जैक्टली शायद वही चीज मिलेगी जो हमारी लिस्ट का ऑपरेशन है. तो लिस्ट के ऑपरेशन और क्यू में सब कुछ कॉमन है except for this new method that I have. So what I'm going to do is I'm going to once again take that list, because not only the signature is the same, but also the semantics of all those methods, they are the same. And I am going to now have this one more method, enrich that list, make a queue out of it, add this one new method to it, and then write the required axioms, and then I will be done with my queue. So this is what I have. So we have this specification of queue. Once again, the element which can also be undefined. This sort queue enrich list, since it is inheriting from the list, imports integer. Once again, the same mechanism that we saw earlier. And we have this new method get queue, which returns two things, element and the queue. So in this particular case, now we have two things. So we write this get in terms of create and cons. It is very simple. When we say get create empty list, so we want to get the top element from the empty list. What we, after chopping the head of the empty list, the element is undefined because there is nothing, so we don't get anything. It is undefined, and we get an empty list. So this is what we get. So we are getting two objects or two entities from this operation. The second method, once again, is cons. So we get cons q comma v. So once again, now we want to take the head of. First of all, what is the head of this new list which we have just created with this cons function? The head of this new list is the same as the head of the old list, that is head of q, except when this q is empty. अगर q empty है, remember हमने वही specification हमने लिखी है जो इससे पहले हम लिख चुके हैं head की, that is it is equal to v if q is equal to create, else it is equal to head of q. And then the other part, that is the modified q, is once again the same. Modified q is the tail part of the q, and this is exactly the same specification that we had in the case of our list, and we simply write that here. So यहाँ पर आपने देखा कि किस तरीके से, यानी not just हमने दो यहाँ पर concept यूज किए. एक तो वो enrich करने वाला, which is the same old concept. With this example, जरा उस concept को reinforce किया गया है, just to show you. But also it shows you that you can, in algebraic specification, you can specify that you can get more than one entities back from this object, and what are the values of those entities you can specify them separately without any difficulty. So ये हमारी ये वाली क्यू की स्पेसिफिकेशन थी. नेक्स्ट जो हमारे पास चीज़ है, आई मीन आई बिन saying this thing again and again, and that is that I said कि जी बहुत सारे जगहों पे ऐसा होता है. फॉर एग्जाम्पल आपका एक स्टैक है and you want to pop, but if you pop from an empty stack, हमने अपनी स्पेसिफिकेशन में we wrote कि we would get a new empty stack. So popping from an empty stack gives us an empty stack. It does not do much harm, but in reality popping from an empty stack is a very dangerous operation. स्टैक को जब एम्प्टी स्टैक को आप पॉप करते हैं तो, या अगर आपका सिस्टम स्टैक एम्प्टी हो और उसको एक पॉप ऑपरेशन आपने फालतू दे दिया, तो इन दोज केसेस व्हाट विल हैपन इज, अगर ख़ास तौर पे सिस्टम स्टैक है तो वो क्रैश कर जाएगा आपका प्रोग्राम. एंड अदरवाइज भी स्टैक की एक सिमेंटिक ये है कि एम्प्टी स्टैक को आपने पॉप नहीं करना, और अगर आप पॉप करेंगे इट इज़ एन एरर. बट वी हैव बिन अवॉइडिंग the specification of the error conditions. Now, since we have seen a lot of specifications, it is time to look at how can we specify the error conditions. So let us once again go back onto the slide and see this example. Here is our list. Everything is same, except now we are going to specify the error condition. So what we are going to do is, the error can be defined or can be tackled in three ways. We can use a special distinguished constant operation like undefined. So when we see a value undefined coming back, that means this is an indication of some sort of an error, and which conforms to the type of the return value, but it indicates an error. We can define the operation evaluation to be a tuple where an element indicates the success or failure. So एक से ज़्यादा चीज़ें हम वापस कर सकते हैं, and then we can return true or false, which would tell us whether the operation was successful or unsuccessful. The third mechanism is we can include a special failure section in the specification. And this is, we will apply when we want to explicitly show an error inside the specification. So here, once again, I've talked about three different mechanisms. ये तीन mechanisms क्या हैं? एक तो वो old C style programming, so to speak, आप समझ लें कि in that particular case you return an error code along with the method. So वो error code is, the type is the same as the return type. So जो चीज़ value आप return करते हैं, that is of the return type, but it indicates some sort of an error. Then we can also indicate, return more than one thing from this function method. और once again ये वही old C style program एक तरीके से आप कह सकते हैं कि if the method is not successful, for example in my pop function in the stack, so what I do is I return not just the element at the top of the stack, but also whether this operation was successful or unsuccessful. So what I will do is I will check if the stack was empty. If the stack was empty, in that particular case, I'm not going to do anything except that I will return the error condition back, and so the user can look at it and take appropriate action. So I can return multiple things from the function, and I've seen कि Q में किस तरीके से I can specify if I needed to return more than one things. जो तीसरी जो चीज है जिसका मैंने जिक्र किया, that was an explicit error section. This explicit error section is very, very similar to our exception handling mechanism in our object-oriented paradigm mostly. In C++ or Java, you would have written exception handling code. So what we do there is we have this try catch block, and in the catch block we have the exception part. So if there is an exception, an error because of some kind of exception, the control goes into the catch block and we handle that exception there. In algebraic specifications, we can also specify our exceptions. And in the case of this particular case, the list example that I'm going to show you now, the axioms for that, we are going to write exceptions when there is an error. So here it is. Let us go back onto the slide once again. So what I want to do is I want to take this exception of the case when I try to get the head of an empty list. Head of an empty list is not defined. In the previous case, I returned this value not defined, undefined. But now I want to handle it differently. I want to raise an exception. So in this particular case, I write the rest of the axioms just like I had written in my list specification. And then I have this last section for exceptions. And here I say length L is equal to 0 means or results in failure of head of L. That is, if I try to take the head of an empty list where L, the length of L is 0, it would result in failure, and that is my exception. So here what I'm doing is I am not specifying what to do, but I am saying that it is a failure, it will be an exception, and then it will go there. So what I'm saying is you cannot take the head of an empty list. It is an error. So now I am not returning an undefined element and then leaving it to the programmer to look at that value and then decide that, okay, that value was not a proper value, it was an undefined value, and hence my operation failed there, and hence I need to take the corrective measure. Here what I'm saying is, sorry, it is an exception. And then, I may take some other measure, other mechanism to resolve this kind of situation, but I am indicating error here. So you can also do that in algebraic specifications. The next example that I am going to show you is, once again, it's a very, very fundamental abstract data type, and that is the type of type Boolean. So I am going to write the specification for Boolean, and then I'll show you what are the alternatives that we have. अभी तक हम जो कुछ करते रहे हैं, we have been writing axioms, writing inspectors, specifying inspectors in terms of constructors, and then showing the behavior, that is, this constructor changes the state of the object, and then if I apply this query onto this, then this is the answer that I will get. That is by kind of indicating, telling me what the change was. Now, in the case of Boolean, I'm going to take a very different approach from the kinds of approaches that we have taken so far. हमने बहुत सारी मुख्तलिफ एग्जाम्पल्स देखी. हमने ये भी देखा कि किस तरीके से रिकर्सिवली हम उसको डिफाइन कर सकते हैं, किस तरीके से कंस्ट्रक्टर्स को इन टर्म्स ऑफ अदर कंस्ट्रक्टर्स हम डिफाइन कर सकते हैं, किस तरीके से हम ऑक्सिलरी मेथड्स को यूज़ करते हुए अपनी स्पेसिफिकेशंस को सिंपल बना सकते हैं. बट हियर आप ये देखेंगे कि किस तरीके से हम ये बूलियन की टाइप को डिफाइन करेंगे. And once again, everything is just logical and it is going to be complete, although शायद देखने में बज़ाहिर ये लगे कि इसमें कोई खामी है, इसमें कोई चीज़ रह गई है, लेकिन जब मैं उसको डिस्कस करूँगा तो आप देखेंगे कि वो स्पेसिफिकेशन अपनी जगह पे कितनी कंप्लीट स्पेसिफिकेशन है. बज़ाहिर देखने में लगती नहीं है. तो कुछ केसेस में हम थोड़े से एक्सियम्स को लिखते हुए हम बहुत कुछ कह सकते हैं. एंड दिस इज व्हाट वी आर गोइंग टू डू फॉर बूलियन. सो हियर इट इज. सो वी हैव द स्पेसिफिकेशन फॉर बूलियन, sort bool. Now in this particular case we are introducing a new concept, and here we have two things. We are defining some constants, and we have these two constants, true and false, which are of type bool. So we will be using these two constants. So these are part of the sort, part of the specification. ये जो constants मेरे पास आ गए. The operations on this boolean that I am going to have, there are 5 operations. Not of a boolean gives us a boolean. And, which takes 2 booleans and it gives me the boolean. Or which takes 2 booleans and it gives me a boolean. Implication, which takes 2 booleans and returns a boolean. And equal, which takes 2 booleans and returns a boolean. बड़ी इंटरेस्टिंग सी ये सिचुएशन है. All the methods, they are returning boolean. So theoretically speaking, जो हम पहले से हमारी डिस्कशन चल रही है, ये शायद सारे के सारे कंस्ट्रक्टर्स हैं. सो फ्रॉम वेयर डू वी स्टार्ट? अब कोई इंस्पेक्टर हमारे पास नहीं है जो रियल टर्म्स में वी आर गेटिंग बूलियन again and again from all these different methods. So what do we do? So we are going to define these using the constants that we have specified above, and then we will be defining some operations in terms of other operations, and I'll show you that the specification is complete. So once again, let us go back onto the slide. The first is not of not A is equal to A. Very interesting. What we are saying here is we are defining not in terms of itself. So what we are saying is we take a boolean, we take not of that, and then we take not of the result, we will get the original value back. अब हमने किसी और चीज को इन्वॉल्व नहीं किया, उसी को यूज करते हुए हमने नॉट को डिफाइन किया इन टर्म्स ऑफ इटसेल्फ. दिस इज नॉट समथिंग दैट वी हैव सीन बिफोर. इंटरेस्टिंग चीज है, जरा इसको ज़हन में रखिएगा. देन वी हैव नॉट ऑफ फॉल्स इज इक्वल टू ट्रू. ये ट्रू एंड फॉल्स हमारे 2 कॉन्स्टेंट्स थे, हमने डिफाइन किए थे. एंड आई एम सेइंग नॉट ऑफ फॉल्स इज इक्वल टू ट्रू. Now the question is, do I need to specify not of true is equal to false? जरा इस चीज के बारे में गौर कीजिए. जरा इसको पहली एक्सियम के साथ रख के देखें, जहां पर मैंने कहा था कि not of A is equal to A. So do I need to specify not of true is equal to false? मैं अगर पहली उसमें चला जाऊं तो मैं ये कह रहा हूं कि not of true is equal to true. So what does that mean? जरा इस पे गौर कीजिए, यकीनन आप इस नतीजे पे पहुंचेंगे कि I do not need to define that not of true is equal to false. Then I have OR of A comma OR of B comma C is equal to OR of A comma B comma C, and OR of A comma B is equal to OR of B comma A. You know, here I am just specifying the normal behavior of OR कि पहले चाहे आप किसी दो को इकट्ठा करके, अगर आपके पास 3 हो तो किसी दो को इकट्ठा करके आप OR ले लें बारी बारी, तो यू विल गेट द सेम रिजल्ट, और इसके ऑर्डर में फर्क नहीं पड़ता. A or B is the same as B or A. So this is what I'm defining, and straightforward thing. Then I have the AND. I say AND of A comma B is equal to not OR of not A comma not B. So what I'm doing here is I am defining AND in terms of OR and not. OR and not मेरे प्राइमरी ऑपरेशंस बन गए, एंड आई एम डिफाइनिंग एंड इन टर्म्स ऑफ नॉट एंड OR इकट्ठा करके. मैंने अलग अलग दो एक्सियम्स नहीं लिखे, एक ही एक्सियम में इन दोनों को इकट्ठा करके. वो डिमॉर्गन्स लॉ अगर आपको याद हो, दिस इज द डिमॉर्गन्स लॉ. मैंने डिमॉर्गन्स लॉ यूज किया है टू डिफाइन एंड. So once again, I do not need to write axioms and in terms of not and in terms of or, बल्कि और and not को दोनों को मिला के and की डेफिनेशन दी है. तो ये एक नेक्स्ट चीज इंपॉर्टेंट इंटरेस्टिंग कॉन्सेप्ट है. Then I have the implication A comma B is equal to or not A comma B. Once again, implication को भी मैंने और नॉट की फॉर्म में डिफाइन कर दिया. वंस अगेन दोनों के लिए अलग अलग नहीं. अब यहां पर मैंने दो सॉर्ट ऑफ, अगर आप इसको कंस्ट्रक्टर आप समझ लें, कंस्ट्रक्टर तो ये नहीं मैं इसको कहूंगा, लेकिन जो हम पहली फॉर्मुलेशन करते रहे हैं, तो यहां पर हमने दो चीजों को मिला के एक स्पेसिफिकेशन दी है एक तीसरे चीज की. तो ये भी एल्जेब्राइक स्पेसिफिकेशन में पॉसिबल है एंड ये लीगल चीज है. देन वी हैव इक्वल A comma B, and I'm saying and implication A comma B comma implication B comma A. तो यहां पर मैं इक्वल को डिफाइन कर रहा हूं एंड इम्प्लीकेशन के साथ, कि मैं ये कह रहा हूं कि इक्वलिटी या इक्वलेंस जो है वो क्या चीज है कि A implies B and B implies A. If that is true, that means A and B both are equivalent. So once again आपने देखा किस तरीके से एक को दूसरे की फॉर्म में डिफाइन कर रहा हूं. फाइनली आई हैव और A comma true is equal to true and or A comma false is equal to A. तो यहां पर मैं और, क्योंकि मेरा एक फंडामेंटल ऑपरेशन था, तो और को मैं डिफाइन कर रहा हूं. मैं कह रहा हूं कि अगर आप और लेंगे किसी भी चीज का फॉल्स के साथ तो मुझे वही चीज वापस मिल जाएगी. अगर और लेंगे किसी भी चीज का ट्रू के साथ, आई विल गेट ट्रू बैक. सो ये फंडामेंटल डेफिनेशन और की है. नाउ द क्वेश्चन इज, डू आई नीड टू डिफाइन एंड? फॉर एग्जाम्पल, डू आई नीड टू से एंड A कॉमा ट्रू इज इक्वल टू A, और दूसरा एंड A कॉमा फॉल्स इज इक्वल टू फॉल्स? Do I need to do that? The answer here is no. Even without that, my specification is complete and I will get this answer because I have specified and in terms of or, and since my specification for or and not is complete, therefore my specification of and implication is also complete. Since my definition of implication is complete, my definition of equivalence is also complete. So मुझे बेशुमार सारे के सारे वो axioms और वो tautologies और वो सारी जो चीजें थी वो मुझे लिस्ट डाउन करने की जरूरत नहीं है. इन्हीं से they are implied and I can get all these. कोई भी आप रिजल्ट आप शो करना चाहें एंड की डिस्ट्रीब्यूटिव लॉ ओवर और वो तो खैर हमने यहाँ पर ऑपरेशन देखा नहीं है, लेकिन एसोसिएटिविटी का जो है एंड की, या जो जिस तरीके से मैंने कहा था कि ए एंड फॉल्स इज इक्वल टू फॉल्स, ए एंड ट्रू इज इक्वल टू ए, अगर मैं इस चीज़ को शो करना चाहूँ, आप देखेंगे with the help of the same set of axioms जो मैंने सिर्फ यहाँ पर डिफाइन किए हैं, I could do that. So this was a totally different approach. इससे पहले जो हमने स्पेसिफिकेशंस देखी हैं उसमें फॉर्मुलेशन वो टोटली इससे फर्क थी. स्पेसिफिकेशंस में जो इम्पोर्टेंट चीज़ जो है वो याद रखने की ये है कि हम स्पेसिफिकेशन हमारी प्रिसाइज और कंप्लीट होनी चाहिए और उसमें कोई एम्बिग्विटी नहीं होनी चाहिए. और वो जिस मैकेनिज्म से भी हम फॉर्मली हम उसको स्पेसिफाई कर सकें, जिस तरीके से हमने यहाँ पर देखा, इससे प्रीवियस एग्जांपल्स में देखा, गो के वी टुक डिफरेंट अप्रोचेस इन डिफरेंट एग्जांपल्स, बट आवर अटेम्प्ट वाज दैट वी डिड नॉट वांट टू लीव एनी डाउट, और इसको इनकम्प्लीट नहीं हम छोड़ सकते थे. कोई एम्बिग्विटी नहीं है, स्पेसिफिकेशन कंप्लीट है, जो आप ऑपरेशन करें उसके वेल डिफाइंड उसमें सिमेट्रिक्स आर प्रेजेंट. तो एज लॉन्ग एज वी कैन डू दैट, हम कोई भी अप्रोच ले सकते हैं. अगले लेक्चर में हम इस गुफ्तगू को जारी रखेंगे एंड आई विल शो यू हाउ टू बिल्ड मोर कॉम्प्लेक्स सिस्टम्स यूजिंग ऑलरेडी बिल्ड सिस्टम्स. उस वक्त तक के लिए आप मुझे इजाज़त दीजिए. खुदा हाफिज़ और अस्सलाम वालेकुम.